Hello friends! On my channel you can see the most detailed reviews of balanced chargers. I not only talk about the menu, but also carry out tests and measurements. I like balanced chargers and have a good understanding of them. This is the English version of my channel, but you can watch the newest reviews on my Russian language channel Pulse Multimedia. The link will be in the description of the video. Today we are reviewing the flagship model from ToolkitRC. The device is called Q6AC. Design is important in any modern device. I think I can guess what inspired the Toolkit engineers. Modern car and charger. They have a lot in common in appearance. Probably the famous SUV from Elon Musk is the main design idea for the Q6AC. But let's not rush. I'll tell you everything in order. The ToolkitRC company is one of the popular manufacturers of balanced chargers today. The company recently introduced its new flagship model Q6AC. There are 4 ports and a total power of 1000 watts. There is fast charging for your smartphone and many useful functions. The video will be long and interesting. I will introduce you to all the functions of this device, perform tests and measurements. My reviews of balanced chargers are the most detailed on the internet.
Компания Toolkit сегодня ведет очень активно.
The Toolkit company today is actively conquering the market of balanced chargers. By creating the Q6AC, engineers probably decided to destroy all their competitors. Let's take a look at the technical specifications. There is a built-in power supply that allows you to connect the charger directly to an outlet. But you can also use an external power supply. For example, you can connect to the onboard network of your car. In this case, the maximum power of the charger will be 1000 watts and a current of up to 50 amperes. All types of lithium batteries are supported, as well as nickel metal hydride and lead-acid batteries. These are the ones installed in your car. The charging power is 250 W per channel when connected to an external power source, and 100 W when powered from a wall outlet. There is a special synchronization mode. It allows you to combine the power of 2 channels into one. That is, you can get up to 500 watts of power on one channel. The discharge power of the internal cooling system is traditionally not high for such balanced chargers. Here it is 12 W per channel. However, there is a cool recycle feature here. I'll talk about it further in the video. It allows you to discharge the battery using a power of up to 250 W, and this is already quite serious. It has built-in 15 W wireless charging for use with your mobile phone.
С вашим мобильным телефоном, но также вы можете воспользоваться и
You can use regular USB outputs to charge smartphones or some gadgets, such as a USB soldering iron. In my videos, I try to explain in detail the technical details about balanced chargers. However, my videos are mainly intended for professionals. If you don't understand something or have questions, I recommend watching my other videos on the Pulse Multimedia channel. There I show in detail all the nuances of working with such devices. All necessary links will be in the description. Sorry, but most of my videos are in Russian. But you can use YouTube's automatic subtitles to translate into any language.
Все полезные ссылки будут в описании к видео, не стесняйтесь, сходите, посмотрите. На многие вопросы найдете ответы. Итак, в комплекте проводов...
There are not many wires included. It's logical. A professional craftsman creates his own wires. Everyone has their own tasks. It is impossible to predict all implementation options. Therefore, the box contains only the most necessary wires. There is an XT90 connector here. This is a fairly rare wire. Thanks to the manufacturer for putting it in the box. This wire is designed to connect the charger to an external power source. A very thick wire is good. Please note that the wires are copper, not copper-plated. This can be seen in the place where the wire is cut. There is also a USB cable and a wire for connecting to a power outlet. There is nothing else. But personally, I don't need anything else. I always solder all the necessary wires myself. The big advantage is that the display is tilted towards the user. In real use, this is very convenient to use. For example, the iCharger device has a completely square body, and its display is turned towards the ceiling. I can't say that this is a good solution. I like that the Q6AC is large in size. It is convenient to operate, unlike the very small iCharger. Let's see what elements are on the device's body. The most important thing here is that there are 4 independent ports for simultaneous operation with 4 batteries. The side connectors have a switch from XT60 to XT30. You just need to move this bolt. Next to each XT60 we see balancing connectors. Left, front,
Слева, спереди и справа.
and right. Please note that these sockets have a recess for any size connector, from 2 to 6 cells. I am now approaching the charger from the ToolkitRC company, which only has a socket for a large connector. To connect batteries with fewer cells, you must use a special adapter. The small connector cannot be inserted into the charger because there is no cutout for locks. Since the device is very powerful, there must be active cooling. There are 2 fans installed at the rear. Their turnover is not constant. The rotation speed depends on the heating of the device. They can work very quickly if necessary. However, when the temperature is low, the charger is quiet and the fans spin without any unnecessary noise. Well done, ToolkitRC. The cooling system here is implemented very correctly. On the left, there is a connector for connecting to an outlet from 100 to 240 V. Nearby we see a switch. This is a cheap and very convenient solution. I can't understand why other manufacturers don't do this. For example, SkyRC or ISDT. Why can't you install a switch for 5 cents? This greatly increases user comfort. On the opposite side there is a socket for connecting an external power source or battery. Usually such a connector is made in the XT60 format, but here there is a very high power of 1000 W. Therefore, the connector was strengthened by replacing it with the XT90 type. Provides power supply voltage from 7 to 30 volts. Nearby we see 2 USB connectors. These ports, as well as wireless charging on top, are used to charge various gadgets. In addition, you can update the firmware via USB. The device controls are simple and convenient. Large non-touch display, channel switching button and navigation wheel. It can be rotated and pressed. The charger is large and I like it.
Достаточно крупная, и мне это нравится. Мне симпатичен его строгий, выдержанный дизайн.
I like its strict black design, unlike some manufacturers who began to produce chargers in Lego and Barbie colors.
А-ля Лего или что-то типа того. Но здесь
The Q6AC is a rugged, masculine look. Looks like a tool for serious work. There are 4 rubber feet at the bottom. The device stands firmly on the table.
при включении нас встречает
After we turn on the device we see a bright colorful display. It displays all the necessary information for 4 ports at once. The high quality of the display is very noticeable. There is an IPS screen with good viewing angles. The image is similar to mid-price smartphones. Some competitors prefer to save on this important parameter. Despite the fact that their devices are expensive, for some reason they install very low-quality screens. Of course we won't be looking at YouTube videos or photos here. But a low-quality TFT display causes great discomfort. Even when viewed directly at a 90 degrees angle, it looks unpleasant. Due to the parallax effect, the images for the left and right eyes have different contrast. Personally, this gives me an unpleasant feeling. Is it worth mentioning that the image on such a screen is not visible from the side? Well done, ToolkitRC. They installed a wonderful high-quality screen here that is a pleasure to use.
Что ж, давайте подключим классический.
To start, I'll connect a classic 6 battery to the charger. Let's see what will be displayed on the screen. To test balanced chargers, I use this homemade battery. How is it arranged inside? How does it connect to the balance jack? I have a separate video about this on the Russian channel. The link will be in the description of this video. If you are interested, you can go and watch it using subtitles translated into your language. Look, Toolkit has a proprietary function that lights up the backlight of the power port depending on its mode of operation. Blue color in standby mode and red color when working with the battery. I think it looks very cool.
Давайте посмотрим, что отображается.
Let's see what's displayed on the screen. We see the input voltage from the built-in power supply, current consumption, and power. Basic information on all 4 channels. And we can see more detailed information on one of these channels.
На примере 18 вольтов.
Now I will take a classic Makita 18-volt LXT format construction tool battery. I want to check how the device will interact with it and what operating modes are available to us.
Мы видим напряжение.
I can see voltage at the power terminals of my battery. It also shows that it is connected to the second port. I can switch channel information by pressing the select button. To start working with the battery, you need to press the control wheel. After this we move to the main task menu. First of all, I need to indicate the type of my battery. The device can work with lithium polymer, lithium high voltage, lithium iron phosphate, lithium ion, lithium titanate, nickel metal hydride and lead acid batteries. A separate menu item calls up the universal power supply function. And the last thing here is the battery charge for various quadcopters manufactured by DJI. My battery has cells with a maximum voltage of 4.2 volts. Therefore, I choose the lithium polymer type. Next, I need to indicate the number of cells in my battery. I choose 5S. There is an interesting and unique feature here. If you do not know how many cells are in your battery, you can set the value to auto. In this case, the charger will automatically detect the number of cells in your battery and make the appropriate adjustments. What's unusual here? Chargers from other manufacturers also have an auto function. Yes and no. The thing is that usually in other balanced chargers the auto function is only available when the balanced connector is connected. The device determines the number of cells based on the number of wires connected to the balanced connector. But Toolkit Q6AC can analyze the voltage on the power contacts and calculate the number of cells of the connected battery. This is a unique feature. I have not seen anything like this in other balanced chargers. However, you need to understand that with such a voltage analysis, there may be a slight error in the measurements. If your battery is outside the permissible voltage limits, for example, it is highly charged or discharged, then the charger may make a mistake with the number of cells. But this is theoretical. I have not encountered an error with the auto function. Everything works correctly for me and the device correctly determines the number of cells in my batteries. We've been a little late on this topic, but I wanted to draw your attention to this important and unusual feature. But we are moving on. Let's see what options are available for working with lithium batteries. Charge, discharge, and storage. These are standard features, but I would add here one useful operation that ISDT has in its balanced chargers. It is called destroy. This feature allows you to completely discharge your battery to 0 volts. This is useful when you are planning to dispose of your battery and don't want your dumpster to start a fire. Now let's look at adjusting the maximum voltage for the charge function. These are very correct values. This range will vary depending on what type of battery you are charging. Well, the last thing we need to adjust is the charge current. Here you can set from 100 mA to 15 amperes. I really like how the menu navigation is implemented. I mean, this is the wheel. If I rotate it slowly, I go through each item in turn. But if I start rotating it quickly, then the menu navigation also becomes faster, jumping through several positions. Dynamic steering. This is the right solution for the navigation wheel. Not all chargers do this. Some other manufacturers also have a navigation wheel, but to move from the beginning to the end of the list you need to rotate it for a very long time. And so I'm ready to start the process, but first I want to show you another very cool feature of ToolkitRC. Before performing a task, I can select the necessary channels on which to run the operation. There are only 4 of them here. You can choose any of the 4 or all at once. It is very comfortable. Usually in other chargers you need to configure each channel separately and this takes a lot of time. Now I press the start button. A warning window appears on the screen. Here we see to what voltage my battery will be charged. We can say that this is a special security system. You can see what I was talking about earlier. I do not have a balanced plug connected. However, the charger correctly adjusted the final voltage according to the 5 cells. 21 volts is the final voltage for my battery. That's right. The number of cells in the battery was determined automatically by measuring the voltage at the power contact. Well done, ToolkitRC. Let's see what information the charger shows during its operation. Current voltage, charge current, amount of filled energy and elapsed time. Look how interesting it is. Using software algorithms, the device calculates the approximate percentage of my battery charge. This parameter cannot be measured in any way, it can only be calculated. To see additional information you need to rotate the wheel. This displays the current operating mode, final voltage for one cell and power. Also here you can see the resistance of the cells connected to the balanced plug. But I don't have it connected right now, so we don't see this information. The total resistance across the power pin in this device cannot be measured. Let's see how the device works when connecting a battery with a balanced plug. To do this you need to take the appropriate battery. I will use a Makita LXT 18-volt battery for construction tools. It has a balanced connector. I upgraded this battery myself. You can see how I did it and how the wires are connected in my separate detailed video. If you are interested in this information, a link to the review will be in the description of this video. Now we can see the voltage across each lithium cell connected to the balanced plug, but the battery resistance is not measured until we start charging or discharging. Let's do that. I click on the navigation wheel and go to the task settings window. You can see that all the parameters are configured correctly and I don't need to change anything. So I just press start. Interesting fact, there is no special separate mode for balancing lithium cells. For example, this is done in chargers from the ToolkitRC company. There you can perform balancing without charging or discharging the battery. In the Q6AC, balancing of lithium cells is always performed automatically if the balance plug is connected. You just need to start the charge or discharge. If for some reason you do not need to balance the battery, then simply do not connect the balance plug. Now look how interesting the balancing process looks on the screen. I have not seen anything like this in other balanced chargers. During operation, you can clearly see what is happening with each cell of your battery. I mean this color indication. It can be red, yellow, or gray. Unfortunately, I did not find any information regarding this indication in the help file. I couldn't understand what the different colors meant. So I wrote a letter to ToolkitRC support and I'm very glad that they answered my question. If all the cells of my battery have the same voltage, then the battery is not balanced at all. The colors of all cells will be gray. But if balancing is performed, the color of the cells changes to red or yellow. You can see that cell number 3 has the lowest voltage, so this cell is not balanced. Work is done with other cells, the voltage on which is equalized relative to number 3. Red color means that active balancing is in progress. Now if you turn the navigation wheel you can see the resistance of all the cells in my battery. But I'll tell you honestly, this is completely useless information. Why? I will tell you in detail further in this video. In general, this device has a lot of interesting functions, I don't even know what to talk about first. So we move on. When a charge or discharge is performed, I can make adjustments to the current value. In this case, the process will not be stopped. To do this, you need to press the navigation wheel when charging or discharging. A small menu will be displayed on the screen in which I can change the current or stop the operation of one or all channels at once. Now let's take a closer look at the discharge mode. To do this, I need to stop the device on channel number 2. Now I select the discharge function. Look what's interesting here. I can use 2 ways to drain my battery, or using the charger itself and this will be low power per discharge. Or I can use another battery as a load. In this case, energy from one battery will flow into another. In general, this method is called recovery, but here the manufacturer called this function recycle. Right now I cannot call this function. I'll tell you more about it a little further in my video. One of the most important parameters in the discharge operation for lithium batteries is the final voltage. I was concerned about the available range of values since there are chargers from other manufacturers that do not know how to properly discharge lithium batteries. For example, ISDT has very good models that generally work correctly, but they have one problem. They cannot discharge a lithium polymer battery to 3 volts or less. I don't know why ISDT made this decision, but it is absolutely certain that this is wrong. The discharge of modern lithium batteries can occur up to 3 and even up to 2.5 volts. This is normal and corresponds to the datasheet of many batteries. This may seem like a small thing, but in reality it is an important factor that prevents me from calling the ISDT devices ideal. That is why, when going to the final voltage setting menu for the discharge function, I held my breath and expected bad news. I said to myself, Toolkit, please don't ruin everything like they did in ISDT. I am very glad that ToolkitRC demonstrated their professionalism. Engineers understand well what they are doing and why. The minimum discharge voltage of the lithium polymer cell can be adjusted down to 2.7 volts. I think that's enough. That's how it should be. Typically, batteries for construction tools or for photo and video equipment have BMS protection, which is triggered when the discharge voltage is approximately 2.8 to 3 volts. Therefore, a discharge of up to 2.7 volts is an absolutely correct and adequate value. In my work and when testing batteries, I usually discharge them to a voltage of 3 volts per cell. I leave the discharge current at 1 ampere. I start the process. Please note that during discharge the cells are painted in different colors. If I understand correctly, this means that balancing is also performed during discharge. The discharge current I specified is 1 ampere, but as you can see, in fact it is only 620 milliamperes. Why is this happening? The answer can be found in this parameter. At the very beginning of my video I showed the characteristics of this charger. There we saw that the declared power per discharge when using the built-in cooling system will be only 12 watts. This is very little. These 12 watts became our power limit on the 5's battery. If you take a battery with a lower voltage, the discharge current will be greater, but still no more than 12 watts per channel. I connected an 18650 battery cell. I set the discharge current to 2 amps. And now, due to the fact that the voltage on the battery is much lower than on the Makita LXT battery, the device will be able to discharge it with a current of 2 amps. We can see that there is even a small power reserve. The current can be increased by a small amount. What should I do if I want to discharge a powerful 5S battery with high current? You might think that recuperation mode would be suitable for this task, but in reality this is not the case. The problem is that this mode transfers energy from one battery to another. The recycle function does not allow energy from your battery to be sent to an external electronic load. Electricity can only flow to another battery. The question then arises, how to discharge the battery into thin air? As we know from physics lessons at school, energy does not appear from anywhere and does not disappear into nowhere. Energy must always be converted into something, for example into heat. But if I want to discharge a 20-volt battery using a high current, then this energy becomes very large. A balanced charger is not capable of dissipating such a large amount of heat inside the Q6AC case. But there is one very cool function that will help us solve this problem. The peculiarity of the device is that it can receive power not only from a 220-volt outlet, but also from an external battery using the XT90 plug, which we have already met. And so look what I want to do. I disconnect the Q6AC from the AC mains. I'll take my 5S battery and connect it to the charger as a power source. This must be the same battery that I want to discharge with high current. Do you see? Our device is turned on. By the way, please note that when using the XT90, the switch located on the side stops working. Now I will take a regular 12-volt light bulb and a wire with alligator clips, but it may not necessarily be a light bulb. You can use nichrome wire, a disassembled iron, a kettle or something similar as an electronic load. I expect that you are all engineers and will come up with a solution to this problem yourself. In general, we need some kind of device that is capable of dissipating a fairly large amount of energy. This should not be an prohibitively large amount, but enough to take 250 watts from our charger. You may think that 250 watts is not very much, but in reality it is many times more than the 12 watts we have initially. I go to the battery type selection menu, but here I choose not the battery, but the function of a universal power supply. I need to set the voltage for my lamp. Since it is intended for a car, the voltage required for its operation is 12 volts, and then I can adjust the strength of the discharge current. If you remember, for this battery the discharge current was no more than 620 milliamps, but now I can adjust the value to 15 amps. This is of course serious. I'll set it to 4 amps, but you need to understand that the lamp will not take more energy than it needs. I start the process. We see how the current and voltage values gradually increase. The light bulb gradually begins to glow at full power. This light bulb is currently powered by a Makita battery. Let me move the lamp to the side so that it doesn't shine in our eyes. And so now the battery discharge current is almost 4 amps and this is already a very good result. I want to draw your attention to a very important detail. Now, during discharge, we can also measure the capacity of the Makita battery in real time. You see here this value changes. And of course, as I said before, during operation you can change the value of the discharge current without stopping the process. Now a very important warning. If I discharge my battery using the universal power supply feature, there is a risk of draining that battery too much, down to 0 volts. To prevent this from happening, you must set the minimum possible voltage for this battery in the settings. Such a voltage will be considered a complete discharge. When it is reached, the process will be automatically stopped. I go to the system settings. We have not seen this menu yet. I'll tell you about it in detail later in the video. Now I will briefly show the function of limiting the minimum voltage on the battery. For a Makita LXT 18-volt battery, the minimum voltage is 15 volts. I specify this value in the settings. Now let's go back a little. I'll tell you how the recuperation mode works. Essentially, it's charging one battery by discharging another. We do not throw electrical energy into the void, but reuse it. Now the charger receives energy through the XT90 plug from the Makita battery. One cell of the 18650 battery will discharge and its energy will flow into the Makita. Thus, the movement of energy occurs as if backwards. We will charge the battery from which the charger is currently running. I specifically indicated in the system settings that the device is powered not from the AC adapter, but from an external battery. When I change these settings, in selecting the type of discharge, I have a new menu item, Recycle. We need to select this line. Now I set the end of discharge voltage to 3 volts for the 18650 lithium cell. The discharge current is 2 amps. And here we see a new very important menu item. You need to specify the maximum possible voltage on the battery into which energy will flow. In this case it is the Makita battery. I specify 21 volts, which corresponds to the maximum charge voltage for this 5S battery. I started the process and recovery began. Now the energy from the 18650 battery flows into the Makita battery. When the voltage on Makita reaches 21 volts, the process will stop, or there is a second condition, if the voltage on the 18650 battery drops to 3 volts. I hope you understand how it all works. Now let's see how the process works for other types of batteries. We have already dealt with lithium polymers. Charge, discharge, and storage. Next, we see the types of lithium batteries. There are several subtypes of them. There is no point in considering each section separately. They are all about the same. Only the voltage at the end of charge and discharge differs. For example, lithium titanate batteries. Everything is the same. Charge, discharge, storage. Only the maximum voltage here is 2.7 volts. By the way, I am often asked why I charge lithium batteries in lithium polymer mode. I answer, because in Li-ion mode here the maximum voltage per cell is only 4.1 volts, and most modern lithium batteries charge at a voltage of 4.2 volts per cell. Essentially, a lithium polymer battery is a type of lithium battery. Let's look further. Nickel metal hydride. The number of cells can be specified from 1 to 16. Available modes are charge, discharge, and cycle. The moment of completion of the charging process is determined by delta peak and is adjustable from 3 to 15 millivolts. If you select the cycle function, several additional options appear. The next item is lead-acid batteries. These are the same batteries that are in your car, uninterruptible power supply, or in the security system of your home. The number of cells can be selected from 1 to 10. The maximum voltage per cell is from 2.31 to 2.51 volts. The minimum voltage range in discharge mode is from 1.25 to 2.25 volts per cell. The universal power supply function is good. No, she's insanely gorgeous. Firstly, there are 4 independent channels. Just imagine, you have 4 universal power supplies. Secondly, the minimum voltage starts from 1 volt. This is actually a very good indicator. In most balanced chargers from other manufacturers, the universal power supply function has a minimum voltage of 5 volts. You can't configure less. But here from 1 to 25. The current value is available up to 15 amperes, but we must remember that ultimately the current will be limited to 250 watts per channel. The last menu item allows you to charge batteries for DJI copters. You must select the appropriate battery model. Mavic 2, Mavic S, Phantom and Inspire. Surely other models will appear here in the future. For these batteries you can purchase a special adapter and connect them to the Q6AC. This is the overview of the main operating modes. We are done. Now we move to system settings. For my Russian-speaking viewers, I even prepared a couple of surprises, which I will talk about later. There are tabs at the beginning of this menu. The first one contains the input voltage settings. You can specify your presets and quickly switch between them. I have the switching type set to Auto. What is the power source for my device? Now I have an internal power supply specified, but I can change this setting to battery power. This item will appear when I connect the battery to the XT90 plug. Maximum power limitation, current limitation, range of permissible input voltages. Why a range and not just one minimum voltage value? Here it is important to have two parameters, maximum and minimum voltage. The minimum value is necessary when our device is powered by a car battery. This is important so that the battery does not overdischarge, and the maximum value is necessary so as not to overcharge my battery in recovery mode. Let's move on. The next tab contains security settings. The first parameter is the internal overheating limit. Next is the operating time limit. Please note that you can configure not only any time, but also completely disable this restriction. I know several models of balanced chargers in which this limitation cannot be turned off. You can only adjust its value. This fully applies to the protection of the energy poured into the battery. You can set the required value or disable it altogether. We are done with this tab and move on. Synchronous mode. What it is? This is a special function that allows you to combine the energy of two separate channels together. Thus, instead of two separate channels, we will get one, but it will have twice the power. In the Q6AC model, this applies only to the ports located at the front. By connecting the battery as shown in the image, you will get not 250, but 500 watts per channel. The next feature is very cool and is essentially a proprietary solution from ToolkitRC. I have not seen anything like this from other manufacturers. It allows you to fully automate work with a large number of batteries. Let me show you how it works. Once I have activated this feature, the charger will not stop working when my battery is fully charged or the battery is changed. For example, I took the same Makita format battery. Let's put it on charge. Number of cells, auto, charge up to a voltage of 4.2 volts. The idea of this function is that after my battery is charged, I can replace it with another without pressing a single button. My battery is very low, so I won't wait for it to charge. I just turn it off halfway and replace it with another one. Do you hear? A beep sounded, but the device did not turn off as usual, but went into standby mode for the next battery. I connect another one, you don't need to press anything. The charging process started automatically. It is very comfortable. It must be taken into account that there are 4 independent ports. Therefore, you can charge a large number of batteries in groups of 4 very quickly and conveniently. Let's say the next battery is charged and the device goes into standby mode. I connect the next battery and the charging process automatically resumes. You don't need to press anything. But we return to our system settings menu. The following parameter activates the trickle charge function. It allows you to fully charge the battery to equal voltage values. This uses low current and short pulses. Of course, this will take additional time, but in the end we will get exactly 4.2 volts per cell. Typically, when we charge a battery, the voltage on it will never reach the target value of 4.2 volts per cell. After charging is complete, the voltage will always be lower. This is how classic lithium battery charging algorithms work. But trickle charge will allow us to increase the final voltage on one cell to an even value of 4.2 volts. Let me show you how it works using the example of a 2S battery from a Canon camera. The full charge voltage here is 8.4 volts. First, I will disable the trickle charge function, and then I will activate it again, and we will see what the difference will be. And so, some time passed and 490 mAh were filled into the battery. The current gradually decreases and at a value of 200 mA the charging process ends. Note that the display shows 8.4 volts, but the actual battery voltage is lower. The screen displays the voltage that was at a charge current of 200 mA. After the process was completed, the voltage dropped. In order for the battery to have a real voltage of 8.4 volts, you need to use trickle charge. Let me now enable this function and see what differences there will be. How will the charging process change? Now the battery charge will be divided into 3 stages: fast, normal and trickle. In fact, each of them is the endpoint of the charge. If you are in a hurry, you can use the battery after completing any of them. The device beeps when major steps are completed. However, when the device goes to the last trickle charge mode, this process is actually very long, almost endless. It will continue until you disconnect the battery from the charger. There will be no beep at the end of this process. The longer the battery is connected to the charger, the more accurate the voltage of 8.4 volts will be. Moreover, during this stage, the voltage is supplied to the battery slightly higher than normal, in short pulses and with a low current. Look here. We have now started a drip charge and you can clearly see what I'm talking about. The device sends a pulse, then there is a pause for a while and then the voltage on the battery is measured. We see 8.31 volts. Obviously, this is not enough to fully charge, and therefore the device gives another pulse with a low current. Here it is charging it. What time is it now? Well, maybe about 5 seconds? And then checks the actual voltage on the battery again. That is, essentially the device works in short stages. Supplies voltage, then turns it off and measures. It feeds again and turns off again. And so this will happen indefinitely, but with a gradual increase in the duration of pauses and a decrease in the charge current. Look, now during pauses the voltage on the battery is 8.32 volts. Let's wait for a while and see what happens next. About 2 hours passed. Now we see that during pauses the voltage on the battery has become higher and is equal to 8.37 volts. This is how it will increase. Moreover, the pulses will become shorter, and the current will decrease. It is precisely because of the decreasing current that we see that the voltage no longer jumps to 8.44 volts, but rises to a maximum of 8.38. Why are we watching this process so closely? To understand how it works. In fact, this is a very important and useful function, but not all balanced chargers work correctly. I see that the Q6AC charger from Toolkit does the trickle charge feature very well. It works exactly as it should. Of course, now we won't wait until the battery is fully charged, because that's a very long time. But as you understand, in the end the voltage on the battery will become exactly 8.4 volts. It is stabilized thanks to the trickle charge function. It's cool features like these that make the Q6AC a truly professional battery tool. Sometimes my viewers write in the comments, why are all these difficulties needed? Take a regular Makita battery charger and don't worry. I answer, this is precisely the advantage of professional balanced chargers, that they can implement such complex tasks. The classic Makita charger usually undercharges batteries and stops at approximately 20.3 volts. But in fact, the full charge voltage for such a battery should be 21 volts. But we return to our system settings. The next parameter is responsible for the battery balancing function. It can be performed always when the balanced plug is connected, or only if the voltage difference between the cells is 100, 200 or 300 millivolts. The next menu item activates a very useful function. This is a special menu in which we can create presets for our batteries. All basic settings such as battery type, required task, end voltage and current are stored here. When such a preset is created, the process of working with the battery starts in just a few clicks. It's very easy and fast.
Следующий пункт в настройках – это яркость подсветки.
The next setting adjusts the brightness of the screen backlight. Next, you can configure the type of sound signal. The bad thing is that the volume is not adjustable. You can only turn the sound on or off. The user can choose one of 7 signal tones. Why they did this is completely unclear. It would be better if the manufacturer added volume control. The following setting allows you to select the menu language. There are a huge number of options here: Portuguese, Italian, Spanish, but unfortunately there is no Russian language. However, as I promised, I have prepared a couple of surprises for Russian-speaking users. Now there are many people who are just starting to get acquainted with such chargers. I understand that it is difficult to immediately understand all the functions and capabilities. Documentation from the manufacturer's website could come to the rescue, but unfortunately it is only in English. Therefore, to help Russian-speaking users, I translated the documentation for the Q6AC charger into Russian. I sent this document to the manufacturer, but I don't know if they will add it to the site. So I have prepared a PDF file and will provide a link to it below this video. Anyone interested can download it. I hope this will help many people understand the management of this device more easily. I would like to believe that I did this for a reason and that my work will be useful to someone. I will be glad if you like this video as a thank you. But the second surprise is even more interesting. Since there is no Russian in the choice of languages, I independently translated the entire menu into Russian. We kept in touch with the manufacturer and added Russian to the new firmware. I hope that you can download the updated firmware with support for the Russian language from the official website of the Toolkit company. But just in case, I will give a link to the firmware in the description under this video. How to update the firmware on a device? You need to connect the device to your computer using a USB cable. Moreover, the Q6AC itself must be turned off. A new disk similar to a USB flash drive will appear on the computer. Just copy the firmware file to this disk and that's it. When you turn on the Q6AC again, the firmware on it will be updated.
Вот мы и посмотрели с вами все доступные настройки.
So we have studied with you all the available system settings. This menu ends with a theme selection function, dark or light. The last menu item allows you to reset all device parameters to factory settings. Now let's check the accuracy of the internal voltmeter and ammeter. Look! Perfect! High precision means our batteries will not be overcharged. But even if over time the voltmeter measurements develop an error, this is not a problem. Q6AC has advanced calibration, not only for voltage, but also for current. Great opportunity! You can accurately calibrate any of the 4 channels. The voltage for the power contacts and the balanced plug is adjusted separately. Current regulation is a unique feature that is very rare in balanced chargers. By the way, let's check how accurately the charger detects and controls the current. This is an important parameter that affects the accuracy of measuring battery capacity. First, let's test the current in charge mode. I set the current to 2 amps. Look! Very good result. The accuracy of the ammeter is comparable to the best balanced chargers on the market. Now let's check how accurately the Q6AC measures the discharge current. In fact, this is even more important because it is during discharge that the battery capacity is measured. I'll take a lithium battery of the 18650 format. I specifically use a battery with 1 cell, because if the battery has low voltage, then the device's power will be enough to discharge and I can set up a high current. I'll try 3 different values in turn: 1 ampere, 500 milliamperes, and 2 amperes. Well, I see a very good result, although the accuracy is slightly less than when charging, but it's worth remembering that the current can be adjusted in calibration mode, and this is a big advantage of this charger. Notice how cool the channel illumination changes. When it is in operation it glows red, and when the process is finished it glows blue. This is very convenient to use because you don't have to go near the device. When viewed from afar, you can understand that the battery is charging or the process has already been completed. Let me check how accurately the universal power supply function works. I set the voltage to 5 volts. I'll try the full charge voltage for a 2S lithium battery at 8.4 volts. This feature doesn't work very well, but I'm not surprised. Traditionally, all balanced chargers have low accuracy of this function. Therefore, you need to understand that such a device cannot become a full replacement for a laboratory power supply. Now I want to say a few words about how well the discharge function is implemented here. Usually in most such devices the discharge current is static. It does not change during the entire discharge process. For example, if I set the current to 2 amps, then with this current my battery will be discharged all the time until the voltage on the battery reaches the minimum value. After this the process will stop. But usually, to check the battery capacity, the discharge current is set to a small value, for example 300 milliamps. This is necessary in order to completely discharge the battery and try to get closer to the minimum voltage value on the cell. The problem is that by choosing low current, the discharge process can last a very long time. Q6AC implements a smart battery discharge algorithm. I can adjust any current, even a large value, and this current will discharge my battery 90% of the time. But when the voltage on the battery drops to a minimum value, the current will begin to gradually decrease to 200 mAh. This algorithm allows you to significantly reduce the time spent testing the battery. In this case, the battery capacity is determined more accurately than at a high current value. Let me show you how it works using the example of a 2S battery for a camera. Throughout the entire discharge time, the current was at 1 ampere. That's exactly how I set it up. But at the end of the discharge, the current begins to gradually decrease to a minimum value. At the same time, the charger clearly controls the voltage on the battery, not allowing it to drop below 6 volts. This is a very correct and smart algorithm for the discharge function. Well, it's been a long video. It is coming to an end. Finally, I would like to give an explanation of one popular question that I get asked in the comments. Which model of balanced chargers measures battery resistance well? Dear friends, I have already answered this question many times, but let me explain again. Not a single modern balanced charger can correctly measure battery resistance. Just forget about this feature. Consider it not there. To correctly measure battery resistance, you must have a special device. I'll show you with an example. I connect a 6S battery. You see, the device supposedly measures resistance. Let's remember the resistance of the first and second cells. Here we have a value of 91 and 78 milliohms. Now I will use a special device that measures resistance using 4-pin plugs. This uses alternating current with a frequency of 1 kHz. Cell number 1, Q6AC, measured 91 milliohms, but in fact, the resistance of this cell is 50 milliohms. Cell number 2, the charger measured 78, but in fact there are 34 milliohms. Thus, as you can see, the resistance that the charger shows us has nothing to do with the real values. These are just some strange approximate numbers. With this information, we can only understand that cell number 1 is worse than cell number 2. Well, overall the device turned out great. I really liked it. What can I say about the disadvantages? I would like to once again draw your attention to the lack of volume control. I talked about this earlier in the video. In my opinion, this is the wrong decision. What else? The time spent is displayed only in minutes. Until recently, balanced chargers from the SKYRC company also worked, but in new models they corrected this shortcoming. But here I just see some 3-digit number, for example 302 minutes, and I have to divide and calculate on my own how much it will be in hours. It is not comfortable. Well, one last thing. There is some strange and obviously unnecessary function here that constantly reminds you that the device needs to be turned off. Guys, why did you do this? This blows my mind. If the charger is in standby mode, then after about 5 to 10 minutes it starts beeping constantly. A message appears on the screen stating that the device must be turned off. At first I thought that this was a special energy saving mode in which it consumes less energy. I checked, but it's not true. Measurements showed that there was no reduction in energy consumption. But in any case, this is very little power. Smaller than any classic LED lamp. Why was it necessary to do this? I don't understand. This is an alarm that constantly makes me nervous. Well, that's probably all, guys. Of course, the video review turned out to be very long, but I tried to talk in as much detail as possible about all the features of this wonderful charger. Can I recommend it for purchase? Of course, yes. I am convinced that this is one of the best balanced chargers on the market today. I hope my Russian-speaking viewers will appreciate the appearance of the Russian language in the menu. Thank you for watching to the end. I want to believe that you were interested and learned something new and useful. And if so, then be sure to subscribe and like. I will be very grateful to you. Don't forget that the newest videos are released on my Russian channel Pulse Multimedia, which you can watch using the automatic translation function in YouTube. Now I'm definitely done. Bye.